have a curve of penetration or a curve of intersection on either side of the cone. So in a similar way to our previous drawing, we're going to start by redrawing. Just going to redraw the given views to my right here so as to keep the dimension. Then we're going to take some section through the elevation, identify each section in the plan, and we project the points back to the corresponding sectional plane. So let's go. All right, so I'm going to start with my center line. Center of the diameter of the base of the cone is 125 millimeters. So I'm going to draw my center lines. Change my line type of construction. All right, circle diameter. I need to find the exact center for that. So I'm going to control, right click, intersection. Wait. Diameter is 125. Right, so I probably can just extend this. So that's my cone in the plan. My elevation for the cone, 125 across. And the height is 120. Vertical height is 120. So I could probably just copy 120, 120. So I get the height, and I can join can remove this. So that's my cone. Now the cylinder has a diameter of 65. All right, so the center of the cylinder is 38 millimeters above the base of the cone. So I'm going to offset this 38. So that should give me the center of my cylinder. Now the cylinder would appear to be a rectangle both in the plan and the elevation based on its orientation here. It has a length of 135. So, all right, 135. So I could probably draw a line, let's say 135. Okay. And I could copy this here. Or center here. Can erase this. I don't need this anymore. Alright. So this is 65. Alright, so 65 of 65. So offset that by 65. 65. And I could probably All right. And I could probably find the middle. Why am I going through all of this? I could probably draw that, find the middle. And if I copy this, and I could probably move this down to the center. Alright. Can just remove this construction line that I would have used. So I could probably just extend this to be a center line. Alright. And let's break that. Break here as well. So I can have my hidden details. Alright, so at this point here, we're gonna have a curve. I don't know where the curve, um, the outline for the curve as yet. So I just have a break in my line so I can do my outline. Similarly here, I'm gonna just break this as well. And I can do the same thing down here. And extend. Alright, so here we go. Can just change this to center line. Alright, so remember we said that we're going to do some section through the cylinder and the cone, and we can just limit the section to where they both intersect with each other. So I wouldn't need to have any section above this, the top of the cylinder, nor below the base of the cylinder. So all of my cutting, my section planes would be between the top and the base. Now, what I can do is to use draw a end section of this and divide it up. So if I look from the right side here, I'll see, or whichever side, I'm going to see a circle. So I can draw a circle to represent the cross section of the cylinder and divide into a number of equal parts. It's what diameter 65. So I'm going to draw a circle here. Circle diameter 65. Then I'm going to divide this into 12 equal parts. So I'm using my polar array. Select polar arrays. Let's select my object. Enter. And select the base points. Now it asks me for the number of elements or items. I'm going to use 12. Enter to accept that. So I divide. Alright, so if I should project a line from here to here, what I'll see. Alright, so I could number these. Let's say I have 0 at the top. Just copy this. So I'll have, let me say 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11. So I'm just gonna change this right around. So that's 1, that's 2, that's 3, 4, 5, 6 at the base, 7, 8, 9, 10, that's 11, and 12 will be back at the top. Let's erase. And let's explode this. Okay. So what I'm going to do next is to project each of these across so I can identify with the numbers. So 1 will line up with 11 and it goes across. So that's one section. Now if I have a cylinder and I cut across the top and look down, I'll see a rectangle. So each of these sections for our cylinder will actually be a rectangle in the plan. Of course, 3 and 9 is right across the center, which is 5 and 7. All right. Now, so each of these gonna be a rectangle as well down here. And for the cone, each section gonna be a circle. So I'm gonna take the first section, number 1, which is 1 and 11, bring it here, and I should get a circle. And I'm going to repeat that at 2. Sorry. Let's delete this circle. It's an error. So from number 2 and 10, I project down, and next I get another circle, right? Next one is 3 and 9. So where that section cuts the cone, I project down, and I'll have another circle for the section across the cone. If you notice, I have not placed a section for the cylinders yet. I'm working with the circle first. Then we're going to draw it from the elevation circle to get the section for the cylinder. Next, and procedure continues. So we draw a circle. And the final one would be 5 and 5 and 7. So where it touches that, and I draw a circle. Now, for clarity, I'm just gonna change these line types. So my section, I'm gonna change my line type for the section. So I'm gonna use that. Let I use the match properties to change these as well. All right. So these are my sectional lines. And I could probably just well, all right, let's leave it at that. One more, which is this one. Remember the center line. I'm gonna just copy one across the center. Copy. All right. Good. So the task now is to identify where these section from the cone intersect with these lines across the cylinder. Now, how do we do that? Now, one technique that I could use is to draw a 45-degree line from here. Project these. We try the center line first. I may have to realign the center line from the plan with this. So I may have to do some realignment right here. Let's shift this up. All right, so I realign the center lines using the 45 degrees. All right. And let's remove these. Now the objective of doing this is to locate each of these sections in the plan. So let's say 1 and 11. But I'm gonna use yellow. All right, so 1. When I project these, so this will be another section. Also, this is 1. Let's copy this. and 11. And obviously this will be 0 at the top, right along the center line here. So I could probably just demonstrate the first 2 points using, so this first cutting plane across here, this will be the rectangle that we see. This. So if we cut across the top of the cylinder, all of this section here, from here to here, would be this. All right. Let me just use yellow. I could probably use a different line type. Just for clarity. So let's look at a different line layer. So this would be my section, right? So my first section and the elevation coming from 1 and 11. And this is how we identify this in the plan. All right, so I'm going to use this as an example and then we proceed from here to get the other point. Now, our first circle, let me change my line, my layer type. It's coming from 1 and 11, which is this. This circle. So we're, this circle intersect with this rectangle, gonna give us 4 points. 2 at the back and 2 at the front. So I could just go ahead now and draw my points. So I use points. All right, so this is 1 point. It's another point. And of course, we'll have 2 more down here. So each point that we locate in the plan view will also be projected in the elevation. So let us project this point up. So this is what? Number 11. So we project 11 up. So that would be a point right here. Point. The first point would be at 0 right here, and it's on either side. All right. And similarly, we project this up to, this is 11, same way. We get a point here. All right. So 0 and 11. So about 1. So 1 here. So 1 and 11. Sorry, 1 and 11 will actually line up. So you have 1 at the front and 11 at the back. All right, so these two will actually line up with each other. So I should do that. All right. So 1 will be at the front and 11 is on the other side of the cone, behind the cone. So we're not able to see this. Now we can try 2 and 10. All right. Let's try 2 because 10 is going to give you the next 2 points at the back. So we can project 2. Or we can project this across. Oh, we're gonna need this in the plan. So let us put this one, 2 and 10. We're gonna need it to complete our plan. So 2, all right. So that's 10 is right here, and 2 is at the front. We follow that. That's 2. All right. That's 2. Oh, should be copy. All right. So let's copy. All right. That's 2 right here, and 10. All right, should be right here. So we look for the circle as comes from here. That's 2 and 10, which is these two. So where they intersect, gonna give us 4 pair of points. All right, all right. So that's 2, is right here. And obviously here, and if we go down here, would be this, and that 2 and 10. All right. Let's go again. I think I missed one. So this is our circle. Okay, so this is the one that should be here. Right here instead. All right. Good. All right, let's go. So it's 3 and 9, which is the center. So we'll project. All right. So 3 and 9 is actually the outer part of the cylinder. So this is 9 right here. Copy. That's 9. And 3 will be on the other side, which is here. All right. So this is 9. This is 3. And let us look at our circle, which is the one right on the center here. So this is our circle. Right. So we're gonna have right here, and we'd have 2 points up here as well. One right here, and one right here. And we continue. So we have 4 and 8. All right. So 4 and 8 would be the same as 2 and 10. So 4. All right. So copy this. So our 4 would be in the same line as 2. And 10, same as 8. So let's match those two now. So section 8 and 2 coming from here. And let's see our circle. So our circle will come from this line. All right. So we have circle and our rectangular section, which is right here. So draw. It's right on. All right. That's 4 and 8. It's right here. Obviously, I'm across here. And the same down here. All right. 4 and 8. All right. So the next one now is 5 and 7. So I can copy this 5. And it should come along here. 5 and 7. So 7 would be in the same line as 11. So 7 is right here. So 7 and 5. All right. All right. And this one should be perpendicular to this. So the point should be right here. And similarly, the very first one here, didn't put that one in the top. All right, so we can put that in. That's 0. So it touches the 0 line right here. It's another point. And of course, we're going to have the same thing on this side. The very one at the top, which is this. Very first one. So we have what? So here we have the outline of the points that will give us our curve for the plan. How about the elevation now? Well, we got these 2 points. We project lines from each of these going up. So I may tend to want to use a different color so as not to confuse. So I'm going to do it on this side. Let's see if I can find a color that we can work with. Use that. All right. So we can start. So we have a point here already. Sorry, draw point. We're gonna start from here. We're gonna have a point here. We have one over this side, and we have a couple at the top. So we're gonna project points from this one. This is 11 and 7. So we go 7 is right here. and 7. So that will be another point. All right, this is 8. That's another point. Um, 8. This is 9. It's another point. All right, 10. 10 is right here. 10 and 8 on the same line. And of course, we have 0 already, and 7. All right. Or if we take it from this side, it would be 1. All right. So 1 and 11. All right. So we have 11. 1 and 11 on that line right here. So we have that. And the same thing would be applied to here, to this side as well. All right, so we'll have a point. Don't have this one as yet. I think this one stops here. So this is what, 1 and 5. 5. All right. We can put this point in. And these two will align. This. I have that already. So we'll get a point here. All right, so this is coming from 2 and 4. So it aligns with 4 right here. 4. This one is coming from 3. 3 is the center line, which is right here. We have this already. All the way at the top, we don't have this one. This is 2 and 4. So it's 2. So there we go. Now I can use a different line type to do my outline. And I'm going to use a spline fit. Take off the auto mode. And I connect these points. There we go. I could use mirror because the object is symmetrical, but I just do both sides so you can have a clear exam. But in an exam situation, you could just use one side and mirror it. If I use a mirror command that I show you, you could do this. See it? And it passes exactly. Let me go again. Mirror. Alright. So it passes exactly through the points on the right side as well. So in a situation where you're doing an exam to eliminate waste of time, you just do one side and you mirror and you get the other side. I would need to plot the points for the other side. Alright, then I'll go now and let's use my match properties to create my outline for the remaining portion of my cylinder and cone. Oh, let's see that. Sure. Okay, yeah, that's fine. All right, let's see, base. Okay, let me just put in the curves for this down here. What line type should I use? All right, so around here would be solid. So I could probably just use break, select break point. Uh-huh. Now I'll repeat the procedure on this side. Break. I select my line and I select point. Right? And I'm going to repeat that. Select line, point, line, point. So use my match properties. I want to see that point. Mhm. Then beneath here would be hidden and here would be solid. So let us use my spline. I will use yeah, construction line. Alright. Now I need to break this. So go right here. Undo. Alright, so all of this portion would be hidden. And this portion would be solid. Alright, so I can just go ahead and just mirror. Alright, because it's symmetrical. So here would also be hidden. I'm using my match properties to create this is hidden, and this piece is hidden as well. All right, so let's see what we have here. Need to complete my front view. Solid, solid, solid. All right, so there we go. So here's our complete drawing. So here we are seeing the line of penetration where the cylinder penetrates the cone. And we have it's symmetrical, so we are seeing the identical curve on either side. And this is our plan. So we are seeing the curve of penetration where the cylinder goes through and exit on the other side. Okay. So once again, the technique that we use here is to draw the given views. We create some sections through the elevation, and to be uniform, what I did was to draw a cross section of the cylindrical portion, the cylinder, and divide in 12 equal parts. And I project each part across, so I get different sections: 1, 2, 3, 4, 5, 6 sections. And each of these sections is represented in the plan as well. I did the first section, which is 1 and 11. And we see we got a rectangle with across here as the same width as 1 and 11 across here, going straight across. So it's as if we take a knife or slice it up right across, and we look down, we see a rectangle. Now when we cut across the cone, we see a circle. So where the circle intersects with the rectangle, we get 4 set of points in the plan. And we project these points back to the elevation to match the corresponding plane to get points up here. 4 actually, 2 at the front and 2 at the back. So this is our solution. I do hope you would have